Quasars are some of the oldest, brightest relics of the early universe that astronomers can detect today. More than 1 million of them have been catalogued in the 50 years since their discovery. Between 9 and 13 billion years ago, there were plenty of quasars in the universe, and if it wasn't for light's time to travel, we wouldn't have even known they existed because of how much time has passed. Today I will teach you about what is a quasar, how did they come to be, and how are they still detected if they most likely don't exist anymore, and why are they so far away? Well, the word quasar stands for quasi-stellar radio source. That name was because at the time of their discovery they looked very much like stars when astronomers first began to notice them in the late 1950s and early 60s. But quasars aren't stars at all, and scientists now know that they are young galaxies, located at vast distances from us with their numbers increasing towards the edge of the visible universe. How can they be so far away and yet still visible? Well, the answer is that quasars are extremely bright, up to 1,000 times brighter than our Milky Way galaxy, and we know that therefore they're very highly active, emitting these staggering amounts of radiation across the entire electromagnetic spectrum. And well, because they're far away, we're seeing these objects as they were when the universe was very young. Light can only travel so fast, and the further we look out, the further sort of back in time we see. I say it like that because we aren't literally looking back in time, it's just light hasn't reached us yet, so we see the light waves that have reached us. Anyway, the oldest quasar currently is J0313-1806. Its distance is approximately 13.03 billion light-years away, and therefore we see it as it was 670 million years after the Big Bang. So, why were they so common long ago, and not so common anymore? That's because they were known to have formed so shortly after the Big Bang, and quasars might actually have been a sort of a once-in-a-lifetime thing. And if it does even occur, it only lasts for a few million years, while the black hole works through all the backed-up material like water swirling around a drain. Once the black hole has finished its sort of cosmic buffet, the accretion disk disappears and the light from the quasar just shuts off, and becomes a normal galaxy. The forming of galaxies is way before our era of the universe. We got here far too late to see any of these events, and, well, it's a little boring for quasars now. But it was approximately 6 million years ago that our Milky Way had endured this too. So, of course, its quasar days are long, long over. So, with this, is a quasar just a young black hole, but, smaller? Well, it's definitely smaller, but it's absolutely not weaker. In fact, quasars are essentially powered by giant black holes, of up to 10 billion times the mass of the Sun, but are no bigger than the solar system. So it emits energies of millions to even trillions of electron volts. And for comparison, trillions of electron volts is up to 1,000 times the energy of the combined luminosity of the 200 billion or so stars in our own Milky Way galaxy. That is 27 trillion times brighter than our Sun. So, with all of that said, it must be the most powerful thing ever, right? Well, actually the most powerful thing ever is gamma ray bursts, but I'll talk about that next time. After decades of intense study, we have another term for these objects, an active galactic nucleus, or AGN for short. I'm gonna keep calling it AGN. There are actually many different types of AGNs, each with their own tale to tell. Theoretically, the intense radiation released by an AGN powers a supermassive black hole at its center. The radiation comes from the material in the accretion disk surrounding the black hole when it's superheated to millions of degrees by the intense friction and movement generated by the frantic particles of dust and gas and other matter in the disk colliding countless of times with one another over and over in such a rapid succession. You can imagine it like putting a gas in a very, very dense container. It begins to heat up, and if you do it for too long, it actually explodes. Of course, without the freedom of explosion, the heat will never stop. Anyway, the inward spiral of matter in a supermassive black hole's accretion disk, that is at the center of a quasar, is the result of particles colliding and bouncing against one another, and eventually they do lose this momentum. That material came from the enormous clouds of gas, mainly consisting of what I call molecular hydrogen, which is fill with the universe in the era shortly after the Big Bang. With these spectacular cosmic lighthouses giving us the information and the life we have today, it is easy to say that, personally, they are the most interesting phenomena I have spoken about yet. Astronomers believe most, if not all, large galaxies went through a so-called quasar phase in their galactic youth soon after their formation. If so, they had subsided in brightness when they ran out of matter to feed on, and the accretion disks surrounding the supermassive black hole, of course, began to fade. After this epoch, the galaxies settled into quiescence, and their black holes were starved of material to feed on. The black hole at the center of our own galaxy has been seen to flare up briefly too, even as it is now, because of passing material straying into it, releasing radio waves and X-rays. It is very much possible that a black hole can tear apart entire stars and consume them as they accidentally slip into its event horizon, the point of no return. As you've seen in the clips and the images and my very rough simulation, it is only seen and recorded when these sharp beams of light are shooting out of the top and bottom axes. So our very short snippets of it are very small, and sadly, that is all we can get from it due to their age and their distance. Now, because the appearance of a quasar depends on the orientation of the rotation axes of the accretion disk relative to the observer's line of sight, it is actually even better for us to see where and what a quasar is because of their ridiculously sharp and finite brightness. Using NASA's Hubble Space Telescope and other space ground-based observatories, astronomers investigating these sorts of phenomena have made an unexpected and rare discovery: a pair of gravitationally bound quasars both blazing away inside two merging galaxies. It is said that in 4 billion years, the Milky Way and the Andromeda Galaxy may do this too. Who knows if the collision will cause such a wondrous effect on our black holes as they slowly meet together. Fun fact, the matter in the galaxies is incredibly spread out, so as a result, rather than crashing into each other, when the Milky Way and the Andromeda would collide, instead of have it going loose, all the planets in the two galaxies would simply get cosmically shuffled. Use the word cosmic a lot today. So, while a planet may find itself with some new neighbours, it's very unlikely that it would be physically impacted by this issue. Thank you for watching.